Okay, guys, thank you for joining. Today, I want to solve with you Leetcode 226, which is inverting a binary tree. If you're like me and you've never encountered binary trees before, don't worry. They seem scary, but they're not that scary, actually. You just have to realize that they are data structures that you can manipulate. So, let's read the exercise. Given the root of a binary tree, invert the tree and return the root. So, even if you don't know anything about binary trees, looking at the difference between the input and the output, you can clearly see what they mean with inverting a binary tree. So if we look at the root node, or at the root, we see a 4 here, we see a 4 here. So the root node stays the same. Now, if we look at the children at the left and the right children of the root node, we see that they're swapped. So the 2 is now here, the 7 is now here. Similarly, if we look at only the left tree, we see that the left node and the right node of the 2 are also swapped. So this is exactly what is meant with inverting the tree. It's basically visiting every node and then swapping its children. So that's also gonna be the algorithm. We're gonna just visit every node and then swap the left and the right algorithm. The left and the right node. Now, so we do that here, and then we get to this node, and we also do it. We do it here, and then we end up at this node, but this node doesn't have any left and right children, so then we go back up the tree. As you can see, this is a perfect way or perfect time to use our depth first search and recursion technique to solve this problem. So let's start with the base case. And if you now, the base case is basically this, where we have no left or rights anymore. So then what we're going to do is we're gonna say, okay, we're gonna stop and we're gonna go back up the tree. So let's go here. So we say, okay, if root is none, or well, if not root, return. We don't need to return anything. And then if we are not in a base case, so if we are in, for example, this one, if we are at the root node, then what we need to do, we are in this node, then we just need to swap the left and the right one. So we just swap the left and the right one. So if we are in a root node, we swap left and the right. So we say swap left and right. Root right is root left. Root right is root right. Root left. And then if we do that, if we swap them, then we also need to recursively call the algorithm, but then on this subproblem, right? And then we need to call it recursively on this subproblem until we end up in the base case, which is covered by exactly the last leaf node. So all that we went to a node, we swapped the left and the right, and now all we have to do is call it recursively on the left and the right node. So call on left and right node until exhausted. So now we say self.invert tree root left, self invert tree root right. And then if we are done, we need to return the root. So let's see if this works. And this works. Cool. So how do we now remember this? We remember this by making flashcards. So let's add a flashcard. And let's copy the description. So how do we invert a binary tree? So once you have this flashcard, you will never ever forget it. Solution. So how do we invert a binary tree? So first we work from the base case. And then we swap left and right children. And then we call, and then we do recursion. So actually it's like just recursion and swap left and right. Now, of course, because we use flashcards, we also need to review our old ones. So what's the brute force solution for containing a duplicate? If it has at least twice, you just go over every array, or you build up a hash map. It's kind of the same. How do you invert a binary tree? This is a card I already added accidentally in a previous take of this video. So we take the base case, then we swap the children, and then we call it recursively. Similarly, what's the solution to 2-sum? Okay, here we try to build up a hash map of the values with the indices, and then we look for whether the complement can be found in the hash map, but not with the same index as the one you're comparing it to. Invert binary tree, we had this already, so we base case, swap the children, and then we call it recursively. Similarly, the space repetition forces you to do it sometimes multiple times. So here for the 2-sum, what we do is we make a hash map of the values as the keys and the indices as the values. And then we go over each element, and then for the complement, we want to look whether the complement is actually in there. Oh, that's a brute force solution. I messed it up, but that's okay. Invert binary tree, base case, swap the children, call recursively. Same base case, swap children, call recursively. And that's it. That's how you remember them. I hope you found it useful. For me, it was also my first time inverting a binary tree. As you can see, it's not very difficult. You just have to, do it, get used to it a bit, and it always helps to try and reduce it to like a base case, and then to see how you can build it up from there. So thank you. Thanks for watching. I hope you enjoyed it, and see you next time.